So guys, today we'll learn about reflection. When we heard of reflection, the first thing that comes to our mind is standing in front of a mirror and seeing our own reflection. So yeah, that is a reflection. But now we'll know the reflection of light. So there's two types, there is standard reflection and another one is diffusion reaction. We'll know about the standard one now. So what exactly is reflection? So let's say you have a wall right here and you project a ball or throw a ball at that wall and eventually the ball will come back. So that could be an example of reflection. Let's just dig deep into it. So let's say I have a normal plane right here. This is a very smooth plane. Just assume that it is. And I project a ray here. And this projected ray will be called the incident ray or I ray. And now, just like the bouncing of the ball, some of it or everything of it will just bounce off, and this ray will known as the reflected ray as it is reflected. So this is the reflected ray. And how does this occur, and what is the principle of reflection, or is the law of reflection? So law of reflection states that if we draw a normal is something that is perpendicular to the plane. So this orange line right here is perpendicular to the plane, so it is normal here. And so this angle here is theta I, and this angle here theta r. As per the laws of reflection, theta I will be equal to theta r. So that's the law. Now don't mix it up by using this angle or this orange angle, so that will end of your lives. Seriously. So now let's do some maths. So let's suppose we have one surface of glass, another surface of glass, and let's say we have another surface of glass. These three surfaces of glass. Now first I incident a ray on the glass. It bounces and goes to this glass, and then again once it goes to this glass, then again it bounces and it reflects, or you could say reflects, and goes to this glass, and then at last, just pull this up for a better view, and then at last the ray goes here. So this is the movement of light, and given that this angle is 135 or 120, let's say 120 degrees, this angle is also, let's say, 120 degrees. These are two equal angles right there. So, and let's say I incident the ray in respect to the plane at what is this? Let's say 30 degrees. Let's say 30 degrees. Okay, now we have to find what is this? What will x be? What is x? So let's do some calculations and find x. So let's draw a normal right here, a 90-degree normal on the plane. So as it is 30 degrees here, this will be automatically 60 degrees. No need to do some calculations. And this here this here will also become 60 degrees, as it is the as said in the laws of reflection that theta I will be equal to theta r. So this is the theta I and this is the theta r in that case. And now we move on, and this will be 30 and it is 90 degrees. And let's say in this triangle, in the downside triangle I'm seeing here, which is 120 this and this is 30, what will be this angle, this orange angle? This will be 180 minus the sum of these two angles. So 180 minus the sum of these two angles is 150. So that will be 30 degrees. So this angle is also 30 degrees. What a coincidence. Now let's draw another normal down there. This normal will be kind of bendy because just tilt your head and you'll find it straight. So in here, this angle right here, it will be 60 degrees again. And so as it is incident angle, this is theta r. So this is 60 degrees and it is the theta r. So it also is 60 degrees and this here will be 30 degrees. That will again be 30 degrees and again this will be 30 degrees, and due to that this let's draw another normal right there. So this will be again 60 degrees, this will become 60 degrees, and eventually x will be equal to 30 degrees. So what's the principle here? We use two mirrors that are aligned side by side at the same angle, and due to this the overall angle of incidence, that is the first initial theta I, let's just say it is initial theta I, and the final theta r, initial theta I and the final theta r, they became equal. So how nice is that? So let's meet another time in another video. Stay tuned, guys.